Today I'm going to go over some revision problems. I think it gives good coverage of most of the things that we've done throughout the semester, and it might serve as good practice material for your upcoming exam. However, I will say that it doesn't cover every topic that we have done, and so you'll have to go through the problem sets from the weekly workshop tutorials to find some suitable additional problems to study. So let's get started. The first question I have prepared here is convert 15 ounces of water to liters. Now ounces is a weight, and we're given that 1 ounce is 0.0283 kilograms approximately. So the first thing we want to do is convert this to kilograms, and the reason why is because 1 kilogram of water is equal to 1 liter of water. That's one of the nice things about the metric system, since water is such a useful resource to life. Okay, so let's get started on this. So first we have 15 ounces, and that's OZ, equals 15. Now I'm going to replace the 1 ounce because that's 15 times 1 ounce. So let's replace that with this conversion, 0.0283 kilograms. Okay, now let's do the mathematics. Take that product and we get 0.4245 kilograms. But 1 kilogram of water equates to 1 liter of water. Okay, so this is 0.4245 liters. Great, that one's done. Next question, solve the following triangle. Okay, so on opposite sides, well, they're not quite opposite. On these two sides here, we've got length 12 units, and we've got 30 degrees, and we've got to find this side, and we need to find these interior angles here. Okay, so the opposite side, let's call that C. So first we can use the cosine rule, which would say C squared is equal to A squared plus B squared minus 2AB cos of angle C, which is 30 degrees. Okay, so cos of 30 is root 3 on 2. Now we've got A is 12, we've got B is 12, so 12 squared is 144. Two times 12 by 12. And cos 30 is root 3 on 2. Okay, so now we can simplify this. Now, we've got a 144 in there. Everything has a 144 common, so let's factor that out. 144 is 12 squared. So there are 2 of the 144s there. We can cancel the 2 here. That got factored out, so we've got 2 minus root 3 times 12 squared. Now if we take square roots, we get plus or minus 12 root 2 minus root 3, but we want the positive one since this is a triangle length. So C is equal to 12 root 2 minus root 3. And that's approximately 6.2 117 or so. Okay, now the last thing we need are the interior angles. We've got one of them, so let's call this alpha and this alpha because those are equal, because we've got an isosceles triangle. So 2 alpha plus 30 degrees has to add up to 180 degrees. So 180 minus 30 is 150, and half of 150 is 75 degrees. Okay, great, that's that one complete. Next one. Consider the vector v with direction minus 60 degrees and norm or magnitude equal to 4. Find the components of v. So let's sketch this. So it would be something like this with length 4. And this angle here would be 60 degrees. Remember, it goes, if it's negative, we need to move clockwise. And if it's positive, it's counterclockwise from the positive end of the x-axis. Alright, so I'm going to sketch a little triangle here. Of side length 4, and we need to work out the side lengths of these two sides. So what we have then is that this side is 4 cos of 60 degrees. So cos of 60 degrees is isn't that 1/2? Okay, and then we need the other one. This side length is 4 sine of 60 degrees, which would be root 3 on 2. Okay, so these are the side lengths. Now the vector goes to the right and down, so we can say that the vector is equal to, now they both have a 1/2 in them, so I'll factor that out to make it look nicer. First component would then be 1 divided by 2, and then the second component is root 3 divided by 2, but it goes down, so it's negative. Okay, so that is it in component form, and in terms of i's and j's, we've got 1/2 I hat minus root 3 onto j hat. Okay, that's that one done. So we're up to question 4 here. Find all angles theta between 0 and 360 degrees such that cos squared of theta is 3/4. Alright, well let's take square roots first. So cos of theta is plus or minus root 3 on 2. Okay, so first, considering, so let's say if cos of theta is plus root 3 on 2, let's find where this is. This will be in the first quadrant. So we can sketch a triangle with side length 1, root 3, and 2, because adjacent on hypotenuse is the cosine of that angle. But remember, we've got this acronym, the CAST acronym, that says that it could be down here as well, right? Because this is positive. Okay, so then theta would be, now this is, we have a 30-60 triangle here. Now this is the smaller of the two non-90 degree angles. So that's 30 there. So we could have theta in this case is plus or minus 30 degrees, which is 30 degrees, or 360 minus 30, which is 330 degrees. Next, if cos theta is minus root 3 on 2, well, we have the same triangle ratio, but The difference is it's in this or this quadrant because cosine is negative there. So in this case, theta would be equal to 180 degrees plus or minus 30 degrees. So in total, we've got theta is 30 degrees. Now 180 minus 30 is 150 degrees. 180 plus 30 is 210. And then we had 330 degrees. Okay, that's that one finished. Let's move on to the next one. Use Simpson's rule to estimate the area under the curve y equals x squared between x is 0 and x is 2 using interval widths of 1/4. Okay, so this one you should set out pretty carefully. Like I would suggest first sketching that. So it looks something like this. So we're going from 0 to 2 and there's 1. Okay, now what I would do normally is sketch this interval from 0 to 2 out a bit wider and indicate where each of the points on the x-axis are that we're going to evaluate the corresponding y values. So this is 1.5, and then we're using step sizes or interval widths of 0.25. So these are all the places where we're going to evaluate y. So this would be x1, x2, x3, x4, x5, x6, x7, x8, and x9. Okay, now they correspond to y values A1, A2, A3, etc. all the way up to A9. Okay, so in other words, we have 9 entries in the matrices that we're going to multiply to use Simpson's rule to estimate this area under the curve here. Okay, so now remember the pattern. We form this matrix H subscript x for Simpson's rule. So we've got our step size or interval width 0.25, divide by 3, and then we write 1, 4, and then 2, 4, and we alternate between the 2's and the 4's. And we've got to have 9 entries here, so it works with this. So that's 6, 8, and then 9. There we go. And then now, as a column vector, but I'm going to write this as a row and then transpose it, so that you should read this as a column, and that's what that superscript T means, to transpose that, so you read it as a column. So now the y values, so y at 0 is 0, y at 2 is 4.0. Okay, but in between we evaluate y of 2.5, so in other words, 0.25, so 0.25 squared, that's 1/4 squared is 1/16, which is 0.0625. Okay, and next we have 1/2 squared is 0.25, then 0.5625, then 1, then 1.5625. I've run out of space here, so I'll have to put them up here. 2.25 and 3.0625, and then 4. Okay, so now H subscript x times the column A gives us the matrix containing the single entry 2.375 when you multiply this by this column here. So you're matching the 1 up with the 0, the 4 up with this with this, and so on, right? Multiplying, and you add the result and then multiply by this. So this is what you get, and so this is approximately the area from 0 to 2. Okay, let's move on to the next question. So we've got a matrix equation, ax equals b. Solve this by Cramer's rule, where a is this, x is xy, and b is 2 minus 1. Alright, so remember your first step is to check the determinants. Well, namely, you want to check whether this has a solution first. So what is det of a? Well, it's 1 by 0 minus 2 times minus 3, so we get 6. That's non-zero, so we know there is a unique solution x to the equation ax equals b. Alright, so now let's go ahead and find that by Cramer's rule. So remember, Cramer's rule would have us calculate this matrix A subscript x obtained by replacing the x column with b and the y column just the same. So I'll put A subscript 2 for the second column of this. Okay, so this is 2 minus 1, and then that column is 2, 0. And then we want to calculate the determinant of that matrix as well. So that's 0 minus 2, which is 2. Okay, similarly, A subscript y is A1 concatenated with B in the second column, because that's the y column. So A1 is the first column of A, so 1 minus 3. Now B is 2, 1. Okay, its determinant is equal to 1 minus 6. Is that right? 1. Alright, I feel like something's wrong. Yeah, that's it. There we go. So that's a minus 1 there. Okay, so this is minus 1 minus 6, which is 5. Great, so we've got our determinants. So then Cramer's rule says that x is equal to the determinant of ax over the determinant of a. And so for that we have 2 over 6, which is 1/3, and y is det ay over det of a. So det ay was 5, so 5 over 6. Okay, now if you want to check, you can check. So the way that you would check would be to multiply the matrix A by x, which we found was 1/3 and 5/6. Okay, do we get B? So this column goes, or this row goes with this column, so we get 1/3 plus 5/3, because 2 times 5/6 is 5/3, then minus 1 plus 0. Okay, 5/3 plus 1/3 is 6/3, which is 2, and then down there we have minus 1. Okay, this is B, so yes, that works. So we have our solution there. Great, let's move on to the next question. Now this is one somewhat different from those you might have practiced in your tutorials, but the principles are the same. So it says find polynomials f and g such that x to the fifth minus x cubed plus 5x squared minus 2x plus 12 is f of x multiplied by x squared plus 2 plus g of x. So we've got to find f of g. So if you think about this, if we take both sides and divide by x squared plus 2, we'll have a division, right? So we want to do a polynomial long division. So we set out x squared plus 2, and then we put this bigger one in the box here, x to the fifth minus x cubed plus 5 x squared minus 2x plus 12. Okay, now what we do first is, maybe on scratch paper, what is x to the fifth? In other words, this leading one divided by this leading one, or leading term. So that's x cubed. Okay, we write that above. Now we take this and multiply by the whole thing, write that below. So that's x to the fifth plus 2x cubed. Now we're going to take a difference. So minus x cubed minus 2x cubed is minus 3x cubed. And this difference here is obviously 0. So, okay, so all of this minus 0 gives just that, so we can copy it down again. Now we just repeat. Okay, so the question here on scratch paper, what is minus 3x cubed divided by x squared? So that's minus 3x. And then we write that above the box. We take that minus 3x, multiply it by all of this, and write it below. So we have minus 3x cubed minus 6. Let's write it way over here, right? Minus 6x. Okay, and the reason I wrote it way over there is so I can line it up with this, so it makes sense when we take a difference. Okay, so this difference here is 0. This difference is 5x squared. This difference is minus 2x minus 6x, which is 6x minus 2x, so 4x. And then 12 minus 0 is 12. Okay, again, this divided by our leading term over there. 5x squared divided by x squared is 5. So we write our 5 up here. We multiply 5 times all of this, and we write it below. So we have 5x squared plus 10, and I'm writing it below the single number there. Okay, taking the difference, we have 4x plus 2. Now notice that this does not divide into this. We do not have a 0 remainder. So what this means then is that this times this equals x cubed minus 3x plus 5 times this, and then plus this, that's that one. So f of x is equal to x cubed minus 3x plus 5, and g of x is equal to 4x plus 2. Okay, great, that one is done. So please try to get better at long division for polynomials. Alright, next one. We've got a 3 by 3 matrix system here. And so we're asked to solve this in two ways, by the Gauss-Jordan procedure and by the inverse of the matrix if possible. Now remember, you were taught how to calculate the inverse of a matrix by the Gauss-Jordan procedure. So what we should do here, if this is A, this is X, and this is B, we can set up the concatenated matrix. So where we put A, then the identity, and then we put B, and we want to row reduce this. So let's put this all together. We've got 1, 1, 0, 2, 1, 3, minus 1, 1, 0, then the identity, and then B. Okay, and the reason we put both of these here is so that we can do parts A and B in the same in the same row reduction, which will make this considerably faster and easier. Alright, so we want to perform row reduction, so I put a tilde to say that these are row equivalent. So the first thing I want to do is replace row 2 with row 2 minus 2 row 1. Okay, so we'll get a 0 here. Keep row 1 the same. So 2 minus 2 is 0. 2 minus 1 is 1. That's convenient. 3 minus 0 is 3. Oh, hang on, is that right? Minus 3, yeah. So what I want to do, row 2 minus, yeah, so no, let's go the other way around, which would be 2 row 1 minus row 2. Okay, because that gives us a plus here. So twice this minus this. So that gives us a minus 3 here. Okay, then 2 minus 0 is 2. 0 minus 1 is minus 1. 0 minus 0. 4 minus 1 is 3. Okay, good. Now, in the third row, we can replace the third row with the sum of row 1 and row 3. Alright, so that's easy. That gives us 0, 2, 0, 1, 0, 1, and 3. Okay, so goal 1 complete. We have 1, 0, 0 in the first column. So next we want to have 0, 1, 0 in the second column if possible. And so we want to get a 0 down below our second pivot. So we've got a pivot there and a pivot there, right? This is our second pivot. We want 0 below it. So now we want to replace row 3 with row 3 minus 2 times row 2, so that we get a 0 below that second pivot. We'll keep row 2 the same for now, and we'll keep row 1 the same. Actually, no, let's not quite keep it the same. Let's replace row 1 with row 1 minus row 2, because we can get a 0 above it quite easily in this step. Okay, so we'll do this one first. So 2 minus 2 is 0. 0 minus 2 times minus 3 is 6. 1 minus 4 is minus 3. 0 minus 2 times minus 1 is 2. 1 minus 0 is 1. 3 minus 2 times 3 is 3 minus 6 is minus 3. We said we would keep the second row the same for now. Okay, now we said we're going to replace row 1 with row 1 minus row 2, so that's 1, 0, 3, minus 1, 1, 0, minus 1. Great, so second goal complete, pivot there, zeros everywhere else in the column. Okay, so now we want to get zeros everywhere else other than in our third pivot. Now eventually we want to have 1 here rather than 6, but that's not my first priority. My first priority is to have zeros everywhere else in that column. So I want to do something a little bit strange here. I want to multiply rows 1 and 2 by 2 so that I have 6's here, and to make it easy to eliminate the non-zero numbers there. And that's replacing row 1 with twice row 1. Replace row 2 with twice row 2. And that's 4. Okay, and then we copy down row 3 as it was. Okay, so now it's really easy to get zeros above this third pivot. So we'll replace row 2 with row 2 plus row 3. Keep row 3 the same for now. Okay, and then we'll replace row 1 with row 1 minus row 3 to get a 0 there. Let's see, so 2 minus 2 is 0, 0 minus 1 is minus 1, minus 2 minus minus 3 is 1. Great, so this is diagonal, that's awesome. We can easily now divide by 2, divide by 2, divide by 6 to complete our goal. And that's replacing row 1 with a half row 1, replacing row 2 with a half row 2, and then we're going to replace row 3 with 1/6 of row 3. Okay, and there we go. So this is in row reduced echelon form, and so we can now read off the inverse of the matrix. And so there's a little bit more that we need to say about this. So we can say that A inverse is equal to the matrix 1/2, 0 minus a half, 1/2, 0, 1/2, minus 1/2, 1/3, 1/6. And in fact, you notice everything's got a denominator, so I can pull out 1/6 in front if I want to. So that would be then 3, 0 minus 3, 3, 0, 3, minus 3, 2, 1. Okay, so 1/6 of this matrix should be our inverse of the matrix. And so B then is equal to, or sorry, X, here we go, X is equal to A inverse B. But we already know what this is. It's this, right? So you may wish to check. So this, with this, gives us 6 minus 3 over 6. So 3 over 6 is a half. Yes, good. This with this gives us 6 plus 3 is 9. 9 over 6 is 3/2. Then this with this is minus 6 plus 2 plus 1 is minus 3 over 6, which is minus a half. So we've done parts A and part B. Okay, next question. So we've got a U, a V, and a W. Find the volume of the parallelepiped with sides given by U, V, W, and other parallel sides. Alright, so remember what we do here. V equals the absolute value of the determinant of the matrix. We just take this and write them here in the rows. Okay, and alternatively we could do absolute value of the scalar triple product U dot V cross W. Okay, but this is an easier calculation here on the left, so we'll do that. So determinant of this 3 by 3 matrix is twice the 2 by 2 determinant, 2, 1, 1, 0, and then minus 1 by the 2 by 2 determinant obtained by crossing out the row in the column that the minus 1 is in, and then plus 1 by the 2 by 2 determinant obtained by crossing out the row in the column that that 1 is in. So 0, 1, 1, 0. Okay, now we simplify. ABS for absolute value. So that's 2 times. So 0 minus 1. Okay. And then this is plus 1 times 0 minus 1. And then this is plus 0 minus 1, which is minus 1, and I'm out of ink now, so I've got to find another pen. Okay, great. So this is absolute value of minus 2, minus 1, minus 1. Hang on, I'm just double checking this. Yeah, this last one's wrong, isn't it? 1 times, yeah, so 0, 2, 1, 1, there we go. Okay, so that's then 1 times, that'll be minus 2. That'll be minus 2. Okay, so this is the absolute value of minus 5, which is equal to 5. Next question, estimate x such that 2 to the power of x squared minus 24x plus 25 is equal to 4 to the power of 3x minus 4. Okay, so there's a clear thing to observe here, right? That 4 is equal to 2 squared. I'm going to try some other pens because this pen's going out as well. Okay, now an exponent rule says we can multiply those exponents, so that's 2 to the power of 2 outside of 3x minus 4, which is 2 to the power of 6x minus 8, and this is equal to 2 to the power of x squared minus 24x plus 25. So now we can just match these exponents and say x squared minus 24x plus 25 is equal to 6x minus 8. We want to take everything to the left-hand side or the right-hand side. So when we subtract 6x from both sides, we get minus 30x, and then 25 plus 8 is 33. Okay, now we have a quadratic equation to solve. So since we don't have a nice factorization, we'll use the quadratic formula. X is negative b, so that's 30, plus or minus the square root of b squared. B squared is easy here. Minus 30 squared is 900. Minus 4 times 33 times a. A is 1. Okay, so 4 times 33 is 132. And that's all over 2a, which is just 2. So simplifying this, we've got 30 plus or minus. Now, that difference is 768. But 768 is 16 root 3. Sixteen is divisible by 2. 30 is divisible by 2, so we have 15 plus or minus 8 root 3, and if we estimate these two values, we have 1.1436 approximately, or 28.8564 approximately. Okay, great, that's that one done. Next question, estimate x such that 3 to the x is equal to e. So e being 2.718281828 and so on. So the log rules would say that x is equal to log to base 3 of e. Now remember, we can choose our own base here by the change of base rule. So this is log to base e of e over log to base e of 3. And you might know this as ln of e over ln of 3. So e to the power of 1 is e. So hence that numerator is equal to 1. The denominator is just the natural log of 3. Okay, so now you can get on your calculator. I'll calculate this on my machine, and I'll just write in log, because my machine understands log to be the natural log. So log of 3 is 1.098 and so on. So we have approximately 1 over 1.09861 and so on. So this division, 1 divided by that, gives approximately 0.910239 and so on. Okay, so now I could just check this, couldn't I? Because 3 to the power of that should give me e. So 3, I'm on my computer now. You can get on your machine and type 3 to the power of 0.9102392266 and so on. So I get 2.71828, right, and so on. So that looks right to me. Okay, great, that one's finished. So this is our estimate. Now I've got one more question. So this one says, consider the data. I've just got some made up data here that I made up myself. Estimate y when x is 7.5. Okay, now notice we're going to do interpolation here, or linear interpolation. So 7.5 is between 5.8 and 8.1. Alright, so I'm going to take the slope, calling this my second point and this my first point. So y2 minus y1, so 20 minus 21 over 8.1 minus 5.8. Okay, I get minus 1 over, now that difference on the denominator is, let's see, is it 2.3? Yep. So I've got a negative slope here. Let's calculate that estimate. minus 1 divided by 2.3, so minus 0.4347, and so on. I'll just chop it off there and call it 0.4347. Actually, if I round it, it's actually 4.4348, so I'll round it. Okay, now with that, what we do is we're seeking the y that goes with x equals 7.5. So I can use this same slope, 4348, and say that I seek y3, so I can put in y1 in the numerator. Okay, now I want to simplify this. So y3 minus y1 I've chosen as 21 over x3 we have as 7.5, and then minus y1 was 5.8. Okay, now 7.5 minus 5.8 is 1.7. And so I want to now solve this equation for y3. So I need to write y3 is equal to minus 0.4348 multiplied by 1.7, and then I take the 21 over to the other side and say plus 21. Okay, and so simplifying this, 1.7 times brackets minus 0.4348 end bracket plus 21, I get 20.2608. Now I look at my data and see if that's reasonable. Yeah, it's between 20 and 21, so that looks reasonable. And so I'll say I'll be satisfied with that approximation there. Okay, so that is all I have for you for now. Now I want you to go through and study a sample of every problem set. Make sure you know how to do those problems. Consult the solutions that were given to you weekly. So those would have been sent out to you via email. So just pick like 2 or 3 problems of each variety from your problem sets, do those and consult the solutions. And I would say that that would be reasonable practice, but if you want to do better, then of course you can do more problems. You've got the tutorial workshop problem sheets, and you've got your book by Washington to look through the relevant sections of that as well to get more problems. I wish you the best in your study and good luck in your exam. Thanks.